Terrestrial planets. Earth-like planets made of rocks or metals with a hard surface. Have molten heavy metal cores, few moons, and topological features such as valleys, volcanoes, and craters. The 4 terrestrial planets in our solar system: Mercury, Venus, Earth, and Mars. There were likely more terrestrial planetoids during the formation of the solar system, but they either merged or were destroyed. Exoplanets. Planets that orbit stars outside our solar system, vary widely in composition and size. Discovered using methods like transit observations and gravitational microlensing. Gas giants. Large planets composed mostly of gases, such as hydrogen and helium, with a small rocky core. The gas giants in our solar system are Jupiter, Saturn, Uranus, and Neptune. These planets are also known as the Jovian planets. Ice giants. Similar to gas giants, but contain a higher proportion of ices like water, methane, and ammonia. Smaller than gas giants, but have thick atmospheres and no solid surface. Examples include Uranus and Neptune. Hot Jupiters. A class of gas giant exoplanets similar to Jupiter, but with very short orbital periods. Dwarf planets. Celestial bodies that orbit the Sun, have enough mass to form a nearly round shape, but are smaller than classical planets. Examples include Pluto, Haumea, and Ceres. Rogue planets. Also called interstellar planets, they do not orbit any star and drift through space untethered to a stellar system. Hot Neptunes. A class of exoplanets with smaller mass similar to Neptune that orbit close to their parent stars. Carbon planets. Hypothetical planets where carbon is the primary component of their rocks. May have surfaces made of graphite or diamond and carbon dioxide-rich atmospheres. Super-Earths. Planets larger than Earth but smaller than ice giants like Neptune and Uranus. Can be made of gas, rock, or a combination of both. Silicate planets. Theoretical planets where silicates, such as olivine and pyroxene, dominate their composition. Rocky surfaces like terrestrial planets, but with different internal structures. Mini Neptunes. Planets less massive than Neptune, but with a thick hydrogen-helium atmosphere, possibly having ice, rock, or liquid oceans. Pulsar planets. Planets that orbit pulsars, which are highly magnetized rotating neutron stars. Chthonian planets. Remnants of gas giants that have lost their outer atmospheres due to their proximity to their parent stars. Tidally locked planets. Planets that have one hemisphere always facing their parent star while the other remains in perpetual darkness. Experience extreme temperature variations between the day and night sides. Ocean planets. Hypothetical planets covered entirely or almost entirely by water. May have a rocky core surrounded by deep oceans and thick atmospheres. Exomoons. Natural satellites that orbit exoplanets. Potential habitats for life if they exist within the habitable zone of their parent planet. Binary planets. Pairs of planets that orbit each other rather than a single star,